SIG Security's documentation subproject has also helped make numerous improvements to the Kubernetes documentation in ways that support good security for all end users.
Our conference co-chairs, Emily Fox, Frederick Kautz, and Ricardo Rocha.
Hello,
Good
everyone.
morning.
Yeah, good morning. Welcome to day 2 of KubeCon CloudNative Con keynote sessions.
That's right.
So today we are going to start out with our Kubernetes project updates, and our fellow co-chair Emily will kick things off.
Thanks, fellas. All right, as many of you know, Kubernetes has been a graduated project since 2018, and these past 4.5 years, the project has continued to mature and develop to meet adopters' needs. Kubernetes development is sustained by thousands of contributors and special interest groups whose dedication and focus to their domain areas make Kubernetes one of the most pivotal infrastructure components of our time. And today, we've got quite a few updates from these special interest groups. So, to kick things off, SIG Security is focused on all things Kubernetes security. This includes evolving community collaboration and partnerships across SIGs and working groups to improve the security of Kubernetes, and they've been very busy. They've developed a new method for self-assessing Kubernetes subprojects and completed the cluster API self-assessment as a pilot of this. They plan to make this process more accessible for future projects and subprojects, and they've also released the CVE feed so that everyone can stay up to date and verify the most recent security fixes for Kubernetes. It's available in JSON, which allows adopters to integrate the feed into their own workflows. And the 2022 security audit allows organizations to continue to remain confident in the security of Kubernetes. You can find this in their repo. SIG Security's documentation subproject has also helped make numerous improvements to the Kubernetes documentation in ways that support good security for all end users. And more recently, and with input from community experts, the security checklist provides a starting point for end users who want to secure their Kubernetes clusters, especially for those that may be overwhelmed by the complexity of container security. This is an amazing resource. I encourage everyone to check it out. On top of all of this, SIG Security continues to focus on inclusion, consent, and mutual support so that everyone can participate in improving the security of Kubernetes together. Please join SIG Security on the Kubernetes Slack channel or come to one of their regular meetings. You could be the next person that helps make Kubernetes safer for everyone. SIG Docs is focused on providing documentation that continues to benefit users and communities with each new feature, enhancement, and best practice through inclusivity and cross-SIG partnerships. SIG Docs is especially proud to announce the localization of Kubernetes.io into Hindi. It is their first use of the Devanagari script, and they are working on localization for Bengali. They are closely partnered with SIG Security on the development and publication of both the CVE feed and the security checklist I talked about previously. And as the scope and use of Kubernetes has continued to grow, multi-tenancy has become more than just namespaces. After collaborating with Multi-Tenancy Working Group, SIG-Docs is pleased to announce the new Kubernetes multi-tenancy overview and best practices, which describes use cases, terminology, access controls, data plane isolation, and so much more. Please join SIG-Docs on the Kubernetes Slack channel. SIG Kubernetes infrastructure has been focused on implementing cost-cutting measures for the cloud infrastructure bill, as they are responsible for managing the build and test infrastructure of the Kubernetes project. The most pressing of these was their storage and bandwidth costs for container images that the project produces. To address this, they've built a proxy service that can route download requests to the cloud of origin. This new proxy is expected to save the project $900,000 a year once it has reached adoption, and everyone here can help. They request the community start downloading immediately their images from registry.kautz.io instead of the previously used kautz.gcr.io. Please spread the word through your company and your community. This will allow Kubernetes infrastructure to put resources towards other initiatives from this immense cost savings. And SIG Storage works in all areas of storage, from file and block store to generic operations on storage. They are thrilled at the inclusion of several long-term efforts becoming generally available features in Kubernetes 125. The local ephemeral storage capacity isolation feature provides support for capacity isolation of local ephemeral storage between pods so that a pod can be hard limited in its consumption of shared resources by evicting pods if the consumption of local ephemeral storage exceeds that limit. The CSI ephemeral volume feature allows CSI volumes to be specified directly in the pod specification for ephemeral use cases. They can be used to inject arbitrary states, such as configuration or secrets, directly inside pods using a mounted volume. The feature is used by some CSI drivers, such as the secret store CSI driver. The CSI migration is an ongoing effort that SIG Storage has been working on for a few releases now. The goal is to move in-tree volume plugins to out-of-tree CSI drivers and eventually move the in-tree volume plugins. With less in-tree code, the risks of a mistake are reduced, and cluster operators can select only storage drivers that their cluster requires. Now, on Alpha and 125, the Container Object Storage Interface, or COSI, enables provisioning and access to object storage in Kubernetes alongside file and block storage. Similar to CSI, it introduces gRPC interfaces for object storage providers to write drivers to provision object storage. Check out the latest blog post on CSI migration on the Kubernetes site and join the SIG Storage Slack channel to help out.
Thank you, Emily. Thank you. So I hope everyone had a good day yesterday and ready for a couple more sessions. So next up, we actually have Nathan Tabor from AWS. Nathan is the head of product for Kubernetes at AWS. Today, he will highlight what AWS is doing to support open source and contribute to Kubernetes. Please welcome Nathan Tabor.
Thanks, Ricardo. Good morning, everybody. Hi, my name is Nathan Tabor, and I lead the product team for Kubernetes at AWS. And I'm really excited to be here, get a few minutes to talk to all of you. At AWS, we love Kubernetes, and of course, we love the CNCF. Our team wakes up every day thinking about how can we improve the lives of our customers and the community that is using and building open source technologies. So I want to talk about a few things that we're doing. And we know that we're not alone here, that we're not doing this on our own. We stand shoulder to shoulder with you and the entire community to innovate and to serve our customers. So this is some of the work that we've been doing. With Kubernetes, we're building the AWS Cloud Provider, contributing to CAPI, and are part of the Security Response Committee. We recently helped implement gzip optimizations, which improve the performance of Kubernetes clients. With etcd, we're bringing our operational learnings from running just so much etcd at scale back into the community. And with Tinkerbell, we have multiple core maintainers. They've done a lot of work updating the Tinkerbell backend from Postgres to native Kubernetes. Amazon is the 4th largest contributor to OpenTelemetry, with 3 dedicated maintainers working on the project. A key contribution has been improving collector tracking and metric stability, including improved Prometheus interoperability with OpenTelemetry. We have 2 Cortex maintainers at AWS, and Amazon is the #1 contributor to the project this last year. We open-sourced a zone-aware controller to make it easier to safely update by zones and speed up highly available deployments on Kubernetes. We also introduced parallel compaction on ingester scalability to reliably support larger number of active time series per tenant. Amazon is the 4th largest contributor to FluentBit. Key contributions that our team has been making include continuous stability and performance testing, introducing priority event loops for performance improvements under load, and multi-line filters. Containerd, as many of you know, is a critical part of Kubernetes. And we have 3 maintainers at AWS, and we're the #1 contributor to Containerd this year. Our team has driven observability improvements, as well as general project health and maintenance alongside the Containerd community. CDK is a really interesting project. This is a project that actually originally came from the AWS CDK project. And we realized, looking at the CDK, that this could, while it was originally made for AWS and CloudFormation, it would actually work really, really well for Kubernetes and could generate Kubernetes manifests just like it was doing for AWS APIs. And so we extended it. And now CDK is a CNCF sandbox project, and the team is working on going towards incubation. Carpenter is another new open source project that just was recently announced from AWS. And it's an open provider cluster autoscaler that's built by the team at AWS that radically changes how capacity is assigned to clusters, provisioning the compute your pods need when they need to scale, and removing the need to think about setting or scaling node groups. We've been thrilled with the community response to the project, and we look forward to building more providers with the community. ACK is a set of open controllers built to allow native Kubernetes provisioning and management of cloud resources. We built this to make it easy for anybody to manage AWS resources using Kubernetes, and we're excited to see this project being used directly by customers in their clusters and as a part of CNCF projects like Crossplane. And we're not just building, we're expanding our contribution to the CNCF, providing up to $3 million in credits. Some of this will be used to maintain and improve the core common CI systems, which deliver CNCF project images to customers, some of the work that Emily was just mentioning before. We're also committed to long-term support for Kubernetes and the entire ecosystem of CNCF projects. With the OpenSSF, we've recently increased our investment to $10 million over 3 years to fund work in securing our shared open source ecosystem. This includes $2.5 million to the Alpha Omega project, money that's used to audit open source libraries, rewrite foundational libraries in Rust, and ongoing security work with the Rust Foundation. And last year at AWS, this is not very visible to a lot of people, but it's very important to us. We've launched a team that we call Find It, Fix It. And this team is focused on finding security vulnerabilities in ubiquitous open source libraries, and then offering the upstream community patches for these vulnerabilities. And in cases where we can, we don't just offer patches, but we actually offer a test suite to ensure that future developments don't reintroduce vulnerabilities. We think this is a sustainable way for communities to help them become more secure over time, rather than just flooding them with a list of security issues and demanding that they fix them. We're excited to keep working with and building Kubernetes with the entire open source community. Thank you very much, and look forward to continuing our partnership.
So our next presenters are Whitney Lee and Mauricio Saltino. Whitney is a staff technical advocate, and Mauricio is a staff engineer at VMware. Today, we are going to show a live demo. They're going to show a live demo to help us understand how to adopt and integrate different tools together to build a platform that your application development teams will love. Please welcome Whitney and Mauricio.
Got no need for the fancy things, all the attention that it brings. Tell me no, I say yes, I was chosen, and I will deliver the explosion. Can't say it's gonna get me far.
Hello, we're so happy to be here. What a gift.
Yes, we are here to have some fun. So are you here to have some fun?
Let's have some
Come
fun.
on,
I'm
let's
gonna
have some
have
fun.
fun.
Let's do it.
Okay. Imagine you're the developer in this diagram, and you work at a company that provides a very important software product, Rainbows as a Service. Now, your company is dominating the Rainbows industry, and it wants to stay on top. So we've commissioned Gartner reports, we put together a think tank of all the industry thought leaders, and we've identified the next big trend in the Rainbows industry.
Do you want to know what it is? Because I really want to know what it is, Whitney. Tell us.
It's spiders.
What?
What? I think spiders are literally the opposite of a rainbow.
That's a little shocking.
So anyway, you're the developer in this diagram, and it's your job now to add the spider to the rainbows and push it to production. And when you do that, your change is immediately live in front of all of your company's end users. This is scary. And I'm not just talking about the creepy spider here. This is scary because if you slow down, if your application has problems, you can slow it down and cause problems for the end users. Or worse, you could be the cause of your company's most dreaded fear. Bum, 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 downtime. These are high stakes.
Well, well, well. Why causing downtime or frustrating your users is something that you should try to avoid. We need to agree that this diagram here is a drastic oversimplification of what happens when a developer pushes code.
Okay,
Right?
I'll give you that. It's an oversimplification. How about this? That's a little more accurate, wouldn't you say?
It looks a little bit better. But where is the developer there?
Oh, okay. The developer's way over there on the left,
Right
and
there.
production's on the right.
Yep.
But don't worry if you don't understand everything that's going on in this diagram. In fact, don't worry if you don't understand most of what's going on in this diagram. The point is for us to show you that it is a lot. It is complicated, and it has to be complicated when you're building complex distributed systems that are meant to scale across millions of users.
That's true, and the question that we are asking and trying to answer during this presentation is how much of this entire landscape do you need to actually understand in order to be efficient at your work?
Yeah. So to begin to answer that question, let's talk about Kubernetes.
By using Kubernetes and the power of the Kubernetes APIs, companies have a clear separation between infrastructure and application development teams. Infrastructure teams can focus on provisioning hardware and VMs if they are working on-premise, or choosing their favorite cloud provider, as most of these cloud providers already support the Kubernetes APIs. On the other hand, application development teams have a very powerful API and a declarative API to deploy their workloads, no matter where that infrastructure lives. So that's a good thing, but we need to agree that this is yet again another drastic oversimplification of what happens.
Well, it's very helpful that application teams now don't have to deal with the infrastructure directly. There are still some challenges. For one, it can be a challenge to train big teams to use Kubernetes. And let's be honest, not every developer wants to learn how to use Kubernetes. Another challenge is that there are so many amazing projects in the CNCF landscape, and it often falls on developers and application teams to research these projects and figure out how best to extend their Kubernetes cluster for their particular use case. And our application team needs to be writing code. They should be thinking about adding the spider to the Rainbows application.
Spiders. So welcome the heroes of our story, platform teams. More larger and mature organizations that have been working with Kubernetes for some long time are starting to create platform teams to build platforms on top of Kubernetes. They do that by trying to understand what tools application development teams need and try to hide all the complexity of installing, managing, and operating these tools, putting everything behind a very friendlier platform API. This platform API can be used by application development teams to self-service, to have access to all these tools and things that they need to work using a self-service approach. Look at that platform.
What a friendly,
Very friendly.
Friendly API. I want to invite them to my birthday party.
You should.
Yeah, I hope they say yes. Okay, so the platform team starts to build a platform first by collaborating with application teams. This is a very important step. They need to deeply understand the tools and processes that the application teams are currently using and what those pain points are. Then they can figure out the best way to help and encode that knowledge into our friendly platform API that then the application teams can access in a self-service way. So for example, our application team needs a development environment to be able to add the spider to the Rainbows application. So our developer asked the Friendly Platform API for that environment. And lo and behold, without any human intervention, that environment gets created. And it has a speedy spider cache and a spider database. And not only that, but the environment comes pre-configured with security and governance policies that the application team doesn't even need to worry about.
There you go. And this takes us to our first demo of the presentation, where we are going to interact with our platform APIs to request a new development environment. So what we are seeing here in this recorded demo, I would love to do it live, but I couldn't. So basically, I'm part of the Arachnid team, and what we are doing here is we are going to request a new environment. And we can do so by sending a request like this, which basically we have extended the Kubernetes API to understand about environments. You can select the type of environment by setting a label, and also then, as you can see there, setting up some parameters that are very, very specific to the needs that I have, right? Like in this case, having a spider database or a cache. So you can see I'm sending like this request using kubectl because it's a Kubernetes resource, and voila, the platform just created an environment for me. You can actually run this demo live. We will share some URLs later on. Because it's a Kubernetes resource, you can query all your environments using kubectl or any other tool in the Kubernetes space, and then you can see there that the environment is not ready yet, but we will use this environment in our next demo, and we will deploy some workloads into that. Yep.
Excellent. So what we just saw was Mauricio interact with the Friendly Platform API, and behind the scenes, the Platform API used Crossplane and Helm together to create that development environment. That development environment is an isolated virtual cluster made with vCluster, and it has Knative serving pre-installed into it.
The good thing about these things is that you don't really need to understand how Crossplane, Helm, Knative, or vCluster works, because that's the whole purpose of having a platform API, a platform team creating these platform APIs that allows us to send a simple request to create a bunch of things for us.
Excellent. So we saw how the platform team can help application teams provision development environments in a self-service way. But platform teams can also make the developer experience better by providing more widely scoped tools that for the application team makes the right thing to do the easy thing to do. So for example, they could create templates and quick starts so that developers can start their projects easily and by following company policies right from the beginning. They can also curate, maintain, and continuously patch tools like CloudNative build packs that automate the way application source code gets built into container images. And finally, the platform can provide a catalog of ready-made solutions that application teams can then extend. So solutions like Tecton pipelines or Helm charts.
And that takes us to our second demo, right? We're going to basically create and deploy a function using a project that is called Knative Functions into the development environment that we just created. So what we are going to see here in the demo is that we are going to first check that our environment is ready to be used. That's why we run that command. It is ready. And now we are going to use vCluster connect because we use vCluster to create the cluster, so we need to connect to it. And now we are in our environment. We can use it. We can do whatever we want in it. And what we're going to do is we are going to create a new function, again, using this Knative functions project. For that, we go into a separate directory. We create our function directory called spiderize because we want to bring some spiders into our rainbows. And then we use this command func create, pointing to a repository that contains some templates. In this case, we are using a template that is called spiders, and that allows us to bring all the things that we need to draw spiders on top of our rainbows. Once the function is created, in this case using the Go programming language, we can change the code, we can modify it any way we want, but we don't have time for that now, so we are just going to deploy it using func deploy. When we run func deploy, this is using, again, this project that is called CloudNative build packs to transform the source code of the function into a container image, so the developer doesn't need to worry about how that transformation happens. And it gives the platform team the ability to curate how that process works. By the end of this command, we are going to get a URL down there in the screen where we are going to click, and we are going to see our function deployed in our environment. So if we click into that link, we should be able to see that now we have a spider on top of our rainbow in our development environment.
So trendy.
It's pretty hip.
I feel so cool right now. So what we just saw is Mauricio connecting to the development environment with vCluster connect command And that environment already has Knative installed into it. So Mauricio could immediately use the func CLI to create and deploy an application without any Docker file or any YAML. And the platform and platform team helped enable this sweet, sweet developer experience by not only providing that development environment, but by providing templates to get started in a quick and easy way, and then providing build packs to automate the build of source code to container image in a company-happy way.
There you go.
Okay, so we saw a couple of ways now that the platform and platform team can improve the developer experience and the development lifecycle. But now, how can the platform team help that finished application find its way to production?
Do you mean that we cannot push straight to production? I really wanted to push.
No, I'm sorry, Mauricio. Developers, under no circumstances, should be pushing straight to production. Instead, we're going to rely again on our heroes, the platform and platform team. This time, they're going to provide tools and best practices to help that application find its way to production. So in this example, we have a GitOps approach to do that. So we have the production environment configuration stored in a Git repo, and we're going to use a GitOps tool like Argo CD. And Argo CD will watch that Git repo, and if any changes are made, they're going to sync that change to the production environment. So then when our application team is ready for the spiderized application to see the spotlight, they submit a pull request. And then automated testing happens, and when all those tests are green, the pull request is merged, Argo sees the change in the Git repository, and then the application is deployed.
There you go. So let's see that in action. And for that, I will walk to my computer to try to do something. It will never work, right? So we are going to take our function into our production environment. And our production environment is actually rainbowsasaservice.com. So if you go to that website, it's actually working there. And we have configured this production environment using a GitOps approach, as Whitney mentioned. And we have this repository called KubeCon Production in my GitHub account, where we are configuring the application using Knative serving here. That's why we have a single YAML just to configure the entire thing. So if we want to apply changes to this application, again, as we mentioned, we will have a pull request with those changes. In this case, we want to add the spiders modifications that we just created. And this is where the platform kicks off, right? Like, this is where we need all the validations to make sure that these changes will actually run in our production environment. So performance test, integration test, all the things that you need to do will be validated here. When this is ready, we can actually merge this pull request to apply these changes into our live environment. So that's exactly what I'm doing right now. So if you accessed Rainbow as a service a bit ago, now you can access again. Because as soon as these changes are done and these changes are synced, we should be able to see all the changes applied into production. And if it's that true, I should be able to refresh here in my production environment, there in the screen. And there we go. We took all the spider from development to our production environment. Hey! It happened. Oh, thank you very much.
So bleeding edge rainbow technology. We got the spider rainbow tag on Twitter is trending so hard right now.
There you go.
All right, so to recap the whole demo, first we use that friendly platform API to self-service provision a development environment. Then, because Knative is already pre-installed into it, we use the Knative func CLI command to get that create and deploy the spiderized application with no Docker file and no YAML. Then the platform and platform team helped our application find its way to production in a safe and automated way.
So Whitney, what do we want people to take away from this beautiful presentation?
The big thing to remember from this application is that platform teams exist to manage all the complexity of getting an application into production. And this frees up application teams to do what they do best, which is to write code. So specifically, platform teams do this by collaborating with the application team to understand what they need and what their pain points are, and then to add that knowledge into the platform API where the application team can access it in a self-service way.
There you go.
The platform team also improves developer experience by encoding things like best practices, architectural patterns, security and governance policies into the platform team, into the platform itself, so that the application team can doesn't even need to worry about it. And finally, the platform and platform team help to automate the path to production in a safe way.
So the bottom line here is platforms and platform teams are there to make application development teams happier and more efficient. And they will take care of taking all the changes and all the cool features that they build safely into our production environment. So one more thing before we go. There is that GitHub URL there where you can actually run all these examples in your laptops or in your Kubernetes clusters. I strongly recommend you to play with these technologies and see how these work. And that's what we got.
That's
all
it.
we got.
Thank you so much, everyone.
All right, everyone. OK, who's ready for CloudNative Project Updates Part 2? We have so many amazing updates. We're excited to present this Part 2. So let's get ready.
That's right. Without further ado, let's dive into the achievements made by our incubating projects. CNCF projects are like our cloud-native cars. There's something for everyone, and they help get you to where you need to be. So let's learn how they're building for the road ahead with these project updates.
All right, you ready? Let's do this. If you've seen this before, it will take a while, but we can handle this. So let's start with KubeVirt. So KubeVirt is a virtual machine management add-on for Kubernetes. It offers virtualization solutions on top of Kubernetes. The recent initiatives from the project include the alignment with Kubernetes releases for improved operations, the introduction of instance type and preference custom resources for a human-friendly way of defining virtual machine resources, and seamless integration with service meshes with PAST, a new user mode network binding that can connect VMs to pod networks. Moving from a monthly release cycle to an alignment with Kubernetes release has simplified this upgrade path, which was a common remark from end users, while also simplifying planning and communication. The version 0.57 focused on continuing stabilization and integration with the broader cloud-native ecosystem, while making steady traction on initiatives for the future. It adds USB support, VM snapshots as an export resource, and improved virtctl support with Windows consoles, expanding functionality for day-to-day operations. KubeVirt has also improved virtctl to support connections proxied by Rancher and added TrillioVault as their first integrated backup and recovery provider. A friendly reminder from the project to be kind with criticisms, patient with the reviewers, and always run your local tests. Now we have Flux. Flux provides GitOps for both applications and infrastructure, with a set of continuous and progressive delivery solutions for Kubernetes that are open, extensible, and secure and scalable. Recent highlights from the project include the advanced support for OCI and cosign, bringing greater security and scalability to GitOps, improvements in the controller and security, including fuzzing and docs for best practices, as well as API consolidation, putting it near to GA. The Terraform controller is something that got the users excited as one of Flux tools that help strengthen the ecosystem. Users have shown excitement as well about the support of OCI in Flux, with the manifests alongside app image layers. The ecosystem continues growing with Terraform integration as well as VS Code and using Flux with OpenShift. Version 0.32 brings greater security for enterprise users, OCI support across all types, all source types, and this is Helm, Customize, Plain YAML, Terraform, Q, etc. The Helm support retains release info, supports dynamic functions, and hooks. The Flux project asks everyone to go ahead and try the Terraform controller, the VS Code extensions, and the UI, which is fully supported by the project. Next up, we have Knative. So Knative was recently included in incubation earlier this year. It's a project that adds components for deploying, running, and managing serverless cloud-native applications to Kubernetes, focusing on improved productivity and operational cost reduction. With Knative 1.8, functions is now generally available, and the same happens for RabbitMQ APIs for broker and source. Knative is also moving from a 6-week release cycle to quarter releases. On the adopter side, the project's downstream, vendors, OSS, and end users will have a better update experience with these fewer releases per year. The RabbitMQ APIs provide a high-performance, out-of-order message delivery alternative to Kafka for those who need it. The project recommends checking the blog post called Enterprise-Grade Serverless on Your Own Terms with C-suite stakeholders to understand the value of using Knative in Kubernetes IT projects. Finally, the project is asking also for feedback and contributions to reduce friction and improve the eventing operating model. Key initiatives include the focus on SBOMs, self-compliance, image, and binary signing. They would love to hear more from both developers and companies.
All right. Emissary Ingress is an open source Kubernetes native API gateway, layer 7 load balancer, and Kubernetes Ingress built on Envoy proxy. Recent initiatives of the project include adding support for HTTP 3 to downstream clients, increased stability and performance, and the project is now built on the latest version of Envoy proxy. HTTP 3 is the latest version of the protocol that powers the internet, so organizations aiming to adopt HTTP 3 protocol can do so with Emissary Ingress and version 3.0. It provides improved performance and increased stability, particularly on lossy networks and use cases such as Edge and Internet of Things. Version 3.0 also provides an upgrade to Envoy Proxy 122, addressing CVEs in older versions of the project and expanding on performance improvements. The project would love to see users experiment with HTTP 3 and welcomes feedback from the community. Backstage is a framework for building developer portals. It restores order to your microservices and infrastructure without compromising autonomy. The project has a lot of initiatives to report. The core framework saw a 1.0 release, a third-party security audit sponsored by OSTIF resulted in 12 main findings, with 8 fixed in 1.5.0 and 4 being assessed in the newly introduced threat model. They've established new communication channels with the software catalog SIG, with more in development, and finally, the growth of the plugin ecosystem has over 70 in the pipeline today. Users have been giving very good feedback from the 1.0 release and the improved security posture through the threat model documentation. And the project has grown in maturity due to a huge spike in public adopters, starting at just 80 at the beginning of this year and well over 200 today. The 1.0 release was a huge milestone for the project. With the current 1.6 version, the project set on a solid release cadence with callouts to security fixes, new plugins, and back-end services for improved scalability and maintenance. The project asks you all to join the community, check the existing plugin ecosystem, and would love to see more plugin contributions, particularly from maintainers of other CNCF projects. Cilium is a networking, observability, and security solution built on eBPF. As a CNI, it provides a simple flat L3 network layer that can span multiple clusters, ingress and egress gateways, service mesh, visibility, and monitoring, among many other features of the project. Project initiatives include the sidecar-less Cilium service mesh and their 1.12 release, which is all the buzz, an ongoing third-party security and fuzzing audit, and the project is thrilled to announce Microsoft AKS CNO is now powered by Cilium. Cilium's continued focus on security will strengthen the defenses of infrastructures adopting Cilium and is a required preparation for graduation. The sidecar-less Cilium service mesh is less complex and has high throughput, lower latency, and reduced resource consumption. The Cilium project also has an LFX mentee to improve its software supply chain security. The project encourages folks to stop by their booth for demos to learn more about the project and to fill out the Cilium user survey. NATS is a connective fabric to exchange data between digital endpoints from microservices to modern cloud-native applications and Kubernetes. It's cloud-agnostic and can be deployed anywhere to bridge Kubernetes, bare metal, VMs, and low-resource hardware. The top initiatives from the project include improving memory usage for Kubernetes, ultra-high scalability, and mobility features, and runtime placement and migration of stream, key value store, and objects. This moves data closer to applications and ensures business continuity during upgrades. With the ability to directly access data with a lightweight API, NATS can support millions of consumers of persisted streams, KV, and object stores. This is useful for Internet of Things, mobile, and any type of application at scale. The 2.9 release is a milestone with improved performance under Kubernetes, greater scale, mobility, and improved stability towards operation at massive scale with zero downtime. The project is asking folks to try installing via Helm charts and would love your feedback.
Cloud Events defines common event metadata and how to expose it in various formats and transports. It enables the quick processing of events without the need to understand the schema and semantics. Recent project initiatives include a draft specification that standardized the component lifecycle of eventing, such as service discovery, subscription management, and event delivery, to new Cloud Events supported formats like XML, CBOR, and translation of Cloud Event specifications to Chinese and Hebrew. Release 1.0.2 has seen steady adoption growth with an increase in end user participation in the working group and request for new features. Falco is a runtime security project enabling threat detection at scale. It observes the application and container behavior, extending threat detection with plugins. Recent project initiatives include a new eBPF probe with CORE and BTF support, support for ARM and gvisor with Falco being able to monitor gvisor sandboxes, and new plugins to detect security threats in GitHub and Okta activity. gvisor has adopted Falco as a complementary solution for threat detection in their security project. The real-world impact for many users that benefited from this collaboration simultaneously is a runtime security isolation in gvisor, and the threat detection audits in Falco improve container security. Version 0.33 brings support for inspecting multiple data sources simultaneously, improved kernel compatibility, stabilized support for ARM architecture, and Falco Control, a new first-class tool to keep rules and plugins up to date. Falco is looking into increasing diversity and participation in the community and is actively seeking new C, C++, and Go developers, and also non-code contributors. Cryo is an OCI-compliant implementation of the Kubernetes container runtime interface, strictly built for Kubernetes. Cryo is reimagining pieces of its stack to be better compatible with edge use cases, with recent initiatives including progress on a rewrite of its container monitor in Rust, bringing better accounting of pod-level resources and a reduction of virtual memory for pods with many containers. It has also added support for alpha kept, such as user namespaces, checkpoint and restore, and release artifact verification with SBOMs and SIGSTOR. Release 1.25.0 was done soon after Kubernetes 1.25, and as always, has been tested in lockstep with Kubernetes release and follows the features added to it. Cryo is eager for new contributors of any variety, and you can reach out on the Cryo Slack channel. OpenTelemetry provides high-quality, ubiquitous, and portable telemetry to enable effective observability. After metrics became stable in May, they've become generally available for Java, JavaScript, Python, and .NET. The project is now focusing on completing and releasing logs as a new signal type with support for existing file-based logs, and eventually a new strongly typed binary format. New workstreams launched for client instrumentation, capturing poor client performance and things like high latency. A new cool demo has been created by the community, which includes different infrastructures, databases, and services written in almost every language. A great way to learn how to quickly gather critical signals from systems and seeing advanced configurations in action. Go and check out the demo, and as always, it's also a great way to get started as a contributor.
We did it.
Oh, we're good. Well done, everyone. I think we had made a lot of progress again from Valencia in just 6 months. It's always good to see the updates. So we're moving on. Our next presenter is Katy Zhang. Katy is a senior principal engineer at Intel who leads their company-wide distributions to the cloud-native and microservice ecosystem. She also sits on the technical oversight committee at the CNCF. She's worked in the cloud field for over 10 years with many patents and authored several white papers and specifications. Today, she will walk us through everything from cores to cloud. Please welcome Katy Zhang.
Turn up the music, turn down the lights. I got a feeling I'm gonna be alright, okay, alright. It's about damn time. Turn up the music, let's celebrate. I got a feeling I'm gonna be okay. Hello, everyone. Welcome to the KubeCon at Detroit. Today, I would like to take 5 minutes to share with you about Intel's perspective on open source, our innovation in cloud computing, and some of our exciting developments in this area. Intel is committed to the success of the open source community because open source provides an incubating platform for innovation. Open source is good for our business, but also good for the entire industry. Intel operates at virtually every layer of the cloud technology stack. We have started to take a software-first approach, and open source community plays a key role in that. Our work in the open source and the close collaboration we have been had with the upstream developers are crucial to our mission and our success. It is our goal to make sure that the open source community is benefiting as much from us as we are from them. One great thing about cloud is that it hides the complexity of the hardware and infrastructure from the end users.
You may think that the low layers of the cloud technology stack do not matter anymore. But after joining Intel for over 1 year, I have realized how important the low-layer work is to the cloud. I have had the opportunity to really dig in and see how efficiency, acceleration, and isolation at the silicon layer can help with cost, performance, and security of the cloud. Just to give you one example about how hardware topology-aware scheduling helps with performance and cost. You may know that the CPU and the memory on a physical server are grouped into NUMA nodes. Obviously, inter-NUMA node communication will be slower than inner-NUMA node communication. Therefore, if the cloud scheduler can take the low-layer hardware topology into consideration, your workload's performance will be enhanced. The CPU and memory on the server will be used more efficiently, which results in lower cloud cost. We all know how important data security is in the cloud. Today's cloud supports data security when the data is at rest or in transit, but not when the data is in use. To fill this gap, we need confidential computing technologies like SGX and TDX to build a trusted execution environment around the data when the data is being processed. Hardware topology-aware scheduling and confidential computing technologies are just two of the areas we have been working with the upstream community to take the cloud cost, performance, and security to the next level. To take the cloud to the next level, there's still a lot of innovation and work to do. The industry is moving from bare metal to virtual machine to container and then to serverless function. Serverless enables developer velocity by offloading from the developer side to the cloud platform side, not just how, but also when to run a workload. Serverless offers many benefits, but it also brings some challenges. Two of the major challenges are cold start latency and auto-scaling speed in response to a burst of traffic. To solve these challenges, we have been working on a new snapshot-based container image to start run a workload, which greatly reduces the cold start latency. We are also developing a new auto-scaling approach to increase the scaling speed when there is a burst of traffic. This is just one example of the innovative work to solve the pain points in the cloud. Intel has contributed to many open source projects. This slide just shows a few of the projects we have been contributing to. As you can see, our contribution to the cloud spans all the software stack. If you are curious, you can learn more about our work at Intel booth in the Solutions Showcase. You may be surprised at what you will see, and we would love to get your feedback. There's a lot more I would like to cover, but I can only say so much in 5 minutes. I would like to say again that Intel is committed more than ever to the success of the open source community. Please continue to give us your requirements and feedback, and please come to see us at the Intel booth. Together, we can do great things and drive more innovation from silicon to serverless. Thank you very much, and I hope you enjoy your journey at KubeCon.
All right, our next presenters are two of my fellow TOC members, Aaron Boyd and Matt Farina. Aaron is a distinguished engineer and director of emerging technologies at Red Hat, and Matt is a distinguished engineer at SUSE. Today, they're following up on the TOC keynote in Valencia to let us know how they are executing on those objectives to improve the way the TOC serves the community. Please welcome Aaron and Matt.
Good morning.
Good morning.
How's everyone doing? Come on. Yeah. All right. All
Hey,
right.
hey, Aaron, what did you mean by the title of this slide?
Well, Matt, continuous improvement isn't a new concept. Derived from the Japanese business philosophy of Kaizen, it's based on continuous improvement of working practices, personal efficiency, etc. Directly translated, it means good change. But you know, in software, we have to make an acronym out of everything, so we call it CI/CD. But the idea of making small, continuous improvements and delivering to the community is really what the TOC is all about.
And you know, the TOC, it really started off small, and it has continuously improved over time. When the CNCF started, there was just one project, Kubernetes. And the TOC eventually added more projects, but there was just a small number that they could do themselves. And then over time, as things grew, as you can see in the landscape slide and things, there were working groups added, special interests group, which became technology advisory groups. And all of the structure scaled with it, and we had to continually change over time as we scaled up. But now, let's get to know who is currently serving on the TOC. Continuously improved over time.
So the TOC represents 10 companies. 3 are from end users, not vendors. And the TOC members work in small, medium, and large companies. They all come from 4 different countries and even 2 different continents. They have varied backgrounds, from expertise in observability, security, container runtimes, and more. As you know, Kathy Zhang, who just presented before us from Valencia, has just joined since then.
We want to take cloud-native computing everywhere, from the desktop to the data center to the edge. Our mission is to take it everywhere in the world into every industry. The TOC does that by guiding technical decisions. You'll see that in the processes surrounding projects, the scope of the technical advisory groups, and more. We try to do this with both innovation and stability in mind.
So Matt, did you know that 60% of people here at KubeCon, it's their first time? Let's give it up for all the first-time people. So the outside looking in, you might think that the TOC is a small group of people who have these, collaborative board meetings, who are jet setters that travel everywhere internationally, have fine dining, and of course, champagne.
But really, we work on a lot of process. We are constantly looking at ways to improve those processes along the way. And we work through all of these processes. With process, you know what to expect, and you know how to be consistent. And I think that's especially important for the projects who go through those processes and want to know what's going on, how do they work through it, and what do they do. And of course, along the way, we listen. When you're dealing with lots of people, it's important to listen so that we can take feedback and continuously improve.
So the TOC is a group of people who not only want to help grow the technical community, but listen and evolve the systems in which we work to ensure its growth is positive and sustainable for the future for everyone. From the technical advisory groups, to the TOC, to ambassadors, to contributors, and the like. We're all working as servant leaders. We want to encourage diversity of thought. We want to create a culture of trust. We want to have an unselfish mindset. And we want to foster leadership in others.
In the end, we're just humans doing the best in service to this community, our talents, our flaws, our idiosyncrasies, and all.
So at Valencia, if you were there, you might have seen the same slide around the cloud-native pillars. Looking at the evolution of the CNC landscape, we would like to outline the main pillars that got us to where we are today. Open governance and transparency is the base of our community. While technical evolution and interoperability created the vast CNCF ecosystem that all of us references, you'll see these pillars as the fundamental underpinnings of servant leadership and how each of these pillars can be expressed. So let's dive a little deeper into open governance and transparency. Outlined in Crossing the Chasm by Jeffrey Moore, the book describes the different phases of new and disruptive technologies. One key function of the TOC is shepherding projects through the 3 stages of the CNCF: sandbox, incubation, and graduation. This means working with projects, doing due diligence, being helpful, sponsoring them, and of course, ultimately voting on the projects. We're constantly updating the process to make it more efficient, create less confusion and frustration for all sides, especially the projects that we're trying to help.
To date, there are 18 graduated projects. These projects include what you need to schedule and run containers, along with projects for security, monitoring, storage, networking, and more. And some of the incubating projects, some that were shown earlier in the updates, they look like they're ready to graduate. So this list may grow in the near future. The 37 incubating projects and 81 sandbox projects bring us to more than 130 total CNCF projects. This has grown immensely since that beginning where there was just that one Kubernetes project. These include a wide range of projects to deal with immediate concerns like security and things we're still trying to figure out, like WebAssembly, and so much more. Today, we would like to unveil a new sandbox submission process. Sandbox is that stage where most projects join the CNCF. Sandbox projects can be experiments, projects where companies want to start collaborating together, and so many other things. The new process takes place over on GitHub, where a majority of the project's maintainers already do their work. It uses issue-based templates. Everything is tracked in the open, and feedback from the different groups on the proposals can all be tracked in one place. This new process is based on listening to feedback, and this is another iteration that we hope improves on the experience for those submitting projects and reviewing them. You can learn more at the GitHub URL up on the slide.
So in light of transparency and open governance, we have meetings twice a month on Tuesdays. In those meetings, we review the technical advisory group updates, we address any open issues, and we constantly take feedback. So please join us.
So let's talk about technology advancement and interoperability. With so many projects, many of which work in the same space, we would like them to work well together, both in collaborating on solving problems and in the way applications communicate with each other. To help the TOC manage so many projects in technical areas, the TOC created the technical advisory groups, which we refer to as tags. The tags cover a wide variety of areas, and if one of these areas, which we're going to go walk through here in a moment, if one of them interests you or you have questions about it, consider reaching out to the tag to learn more.